Okay, hello students, and welcome to today's Friday Math Happy Hour. Today we're going to be covering, I believe, a little bit of Chapter 5, which is verifying trigonometric identities and implementing trigonometric formulas. Okay, now guys, this is something that the topic that we're going to go over. Okay, this is section 5.1 and 5.2. First of all, find the 6 trigonometric functions by using trigonometric identities. I believe last week or 2 weeks ago, not 2 weeks ago, we did these, right? But it was using the right triangle. Now there's going to be another way to find the 6 trig functions by using the identities. Number 2, we're going to be simplifying trigonometric expressions by using the identities. Factor trigonometric expressions. Adding trigonometric expressions, and verifying trigonometric identities. Okay, now guys, these are a must. You have to know these. Okay, I believe at the lab, at the lab at VV and also at Trans Mountain, they have like a formula sheet, and all these are there. It's wise for you guys when you're going to be doing these sections to have these at your disposal. That way you'll be looking at them while you try to identify, to verify the identities, and also when you factor. Okay. The first ones are called the reciprocal identities, which is sine of u equals to 1 over cosecant u, and cosecant u is 1 over sine u because the sine and the cosecant are inverse of each other, and so are the cosine and the secant, and the tangent and the cotangent. The cosine of u is equal to 1 over secant u. And secant u is equal to 1 over cosine u. The tangent is equal to 1 over cotangent, and the cotangent is equal to 1 over tangent. Now these are called the quotient identities. Tangent u is equal to sine u over cosine u. And the cotangent u is equal to cosine u over sine u. And finally at the bottom, these are called the Pythagorean identities. Sine squared u plus cosine squared u is equal to 1. 1 plus tangent square u is equal to secant square u, and 1 plus cotangent square u is equal to cosecant square u. Throughout the PowerPoint, I'll be referring to these. Okay. Again, we need to know these. Example number 1. It says using identities to evaluate a function. Again, here, guys, I believe we already did this in the second week, but we did it by using the right triangle. Now they want us to use the identities. Okay, so they say given the secant of u equals to negative 3 over 2, and the tangent of u is positive, right? It's more than 0. Find the values of all 6 trigonometric functions. Okay, so first we have to know what the quadrant of both conditions. For example, the secant of u, right, is equal to 1 over cosine. So we know that we're looking at the cosine, right? So we have to see where the cosine is going to be negative, right? So this is the secant of u is negative 3 over 2. So the cotangent is a reciprocal, right? Because these two are inverse of each other, so it'll be negative 2 over 3. So in what quadrant is the cosine positive, right? If we notice, guys, the quadrant is going to be quadrant 2 and quadrant 4. No, quadrant is negative. It will be quadrant 2 and 3. My bad, quadrant 2 and 3. Okay. Now we find the condition where the tangent is positive. The tangent is positive, right, where the signs are the same. For example, it's going to be tangent 1 and tangent 3. Now, where do they both intersect? The quadrant is going to be quadrant 3. So the answer will be in quadrant 3. That's the first thing you guys have to do when you're trying to solve the right triangle. To solve or find the 6 trig functions by using the identities. So we know that everything that has a sign is going to be negative. For example, the sine in the cosecant will be negative, and also the cosine in the secant will also be negative, and the tangent and cotangent will be positive. Okay, and now refer to this later on. Example number 1. Okay, now which identities can we use from the previous slide? Okay, because they only give us secant and nothing else, right? And we cannot use the right triangle, right? Because they don't want us to do it that way. So which one here has secant, right? So the secant is over here, right? So we're going to use this one first. 1 plus tangent a square u equals to secant square u. Okay. So the secant is negative 3 over 2. So I'm going to plug in negative 3 over 2 where the secant is. Right? But it's going to be squared because the secant is squared. Now the next step, right, to solve for tangent, I'm going to subtract 1 from both sides and also simplify the negative 3 over 2 squared is going to give us 9 over 4 minus 1. Okay? 9 over 4 minus 1 is equal to 5 over 4. Now we take the square root of both sides. So tangent of u is equal to the square root of 5 over 4, which this will be the same thing as square root of 5 divided by square root of 4. The square root of 4 will give us 2. So the tangent of u is equal to square root of 5 over 2. Okay, now once we have the tangent, we also found the cotangent. Right, the cotangent is a reciprocal. Right, but I believe if you put this in this order, and I mean on web assign how it is, 2 over square root of 5, I believe it will kind of right. But most instructors, they want you to simplify to the extreme, which means you have to rationalize the denominator. You can have a radical one at the denominator. So what we do here, guys, we multiply top and bottom with the square root of 5. So it's going to give us 2 square root of 5, and on the bottom, square root of 5 times square root of 5 will just give us 5. We got the secant, we got the cosine, we got the tangent, and we got the cotangent. So we're missing the sine and the cosecant. Okay, let's continue on the next slide. And again, guys, right? So we have, let's see what we have here. We have the cosine of u, right? From before it was negative 2/3, and the secant of u was negative 3 over 2. The tangent will give us the square root of 5 over 2, and the cotangent will give us 2 square root of 5 over 5. Okay, so I found 4 of them. Now we're missing one more. So because we're missing the sine and the cosecant, we're going to use this identity here. The Pythagorean theorem, the Pythagorean identity. Okay, so here, guys, we know what the cosine is, right? The cosine is negative 2/3, so I'm going to plug it in for the cosine. Now to solve for sine, this will give us 4 nines, right? So it will be 1 minus 4 nines. Okay, which will give us 1 minus 4 nines will give us 5 over 9. Now we square root both sides. So we know that the square root of 9 will give us 3, so 3 will be the denominator, and then on the numerator, it will just be square root of 5. So the sine of u will be square root of 5 over 3. Right, so then once my cosecant of u will be the reciprocal of the sine, which will be 5 over 3, will give us 3 over square root of 5. And again, we have to rationalize the denominator. So if we multiply numerator and denominator by the square root of 5, it'll give us 3 square root of 5 over 5. So we have all the identities, right? And now to verify that this is a correct sign for each quadrant, right? We know that everything that has a sign is going to be negative. So the cosecant and the secant are going to be negative, right? That was going to be negative, and also the cosecant will also be negative. Everything with the cosine also has to be negative. The cosine and the secant must also be negative. You see, and they are here on top. And the tangent and cotangent are going to be positive, which they are. So this is a correct sign and the correct values for each one of those. That's how you solve these. Okay, now this is number 7 from the homework. I believe for this section, for this particular section, 5.1, I did the examples in order, and I did one from the homework, and then I did for after every example, I did one from the homework. Okay, so this is number 7 from the homework. This is very similar, right? But everything's different, right? They give us a different. Before they give us a secant, now they give us a sine, and now we have to know whether cosine is also positive. So now, first of all, right, we need to know the condition of what quadrants the condition meets here. So the sine is negative, so that's going to be in
Mr. Azasi's accidentally disconnected. He'll be right back in a moment. Sorry for the wait.
Over 4, so the secant will be 4 over square root of 7. And we have to simplify it, right? We have to rationalize the denominator, so it's going to give us 4 square root of 7 over 7.
Mr. Isasi,
you disconnected for a few minutes, and your screen and your share, everything cancels out.
How can you go? Okay, let me go back. Okay, let me. So how can I do that? Can I just go back? But how am I going to enter the?
You'll just have to reshare.
Okay, let's see here. Let me go back. Okay, so let me do it again. I don't know what happened here. Let me share the screen. Do you know where I left off, guys? Which one was I doing? Okay, I'm going to start here again, okay? On number 7. Is that okay with you guys?
That's good, sir.
Okay. I'm sorry about that. Okay, now here again, number 7. It says find the values of all 6 trigonometric functions. So the first thing we're going to do is find the condition of each one. Which each one meets. What quadrant are they going to be on? Okay. So the sign is negative, right? The sign is going to be negative in quadrants 3 and 4. So it's going to be 3 and 4. And the cosine is going to be positive in quadrants 1 and 4, right? Because here you see quadrant 1 is positive, quadrant 4 is positive. So where do they intersect or where do they meet is quadrant 4. So my answers are going to be in the signs from quadrant 4. Okay, now I need to, let's see what's given. What's given was a sign, right? So we know that we have to use the first Pythagorean identity, which is sine square u plus cosine square u equals to 1. Okay, I'm going to plug in the negative 3/4 where the sign is. Okay, so negative 3/4 squared is going to give us 9 over 16. If we subtract 9 over 16 from both sides, it's going to give us cosine squared theta equals to 9 over 16. Okay, now what's 1 minus 9 over 16? It's going to give us 7 over 16. Now here, guys, we're going to square root both sides. So if we do that, it's going to give us the square root of 7 over 16, which will give us the square root of 7 over 4, because the square root of 16 will give us 4. So I found, right, my sign is what's given, negative 3/4. So when we find the sign, we also find the cosecant, because the sine and cosecant are opposite reciprocals of each other. So the cosecant will give us negative 4 over 3. We just also found the cosine. The cosine will be square root of 7 over 4. Right, so when we find the cosine, we also found the secant, because the cosine and the secant are also opposite reciprocals. So it's going to give us 4 over square root of 7. We have to rationalize the denominator. We multiply top and bottom by square root of 7, so it's going to result in 4 square root of 7 over 7. Now we're missing the tangent and cotangent. Okay, let's go to the next slide. So this is what we have so far. Okay, we're missing the tangent and cotangent. So then, what can we use? We know that tangent is equal to sine over cosine. Hey guys, there's different ways to get the answer. I can even use the other identity, the Pythagorean identity, which was 1 plus tangent squared theta equals to secant squared theta, or 1 plus cotangent squared theta equals to cosecant squared theta. You see, there's different ways or different options to go here. Okay, but I decided to use a tangent because tangent is opposite. It's a sine over cosine. You see, we have our sine, we have our cosine. So the is going to be negative 3/4, and the cosine will give us negative the square root of 7 over 4. Okay, here guys, right here is a complex fraction, right? We're dividing, so negative 3/4 divided by square root of 7 over 4 is going to give us negative 3/4 times the reciprocal of the second fraction, which will be square root 4 over square root of 7. If you notice, the 4's cancel here, right? 4 divided by 4 will give us 1. So the result is negative 3 over square root of 7. Now we have to rationalize the denominator again. If we do that, the result will be negative 3 square root of 7 over 7. Okay? Now, when we found the tangent, we also found the cotangent. Because the cotangent is going to be the reciprocal, right? But we don't go here. We can just come over here where it says negative 3 over square root of 7. What's the reciprocal of negative 3 over square root of 7? It's going to give us negative square root of 7 over 3. So that's my cotangent. So I found my 6 trig functions. Okay. That's how you do number 7. And also I believe there's some more, most instructors will assign these for homework. Because here, guys, you have another option. Instead of using the right triangle, you can always use the identities. Okay, and you see that's where it came from. And again, let's check the signs, right? Everything with a sign is going to be negative. The sign is negative, and also the cosecant, they're opposite reciprocals of each other, so that's good right there. Everything with a cosine is going to be positive, so the cosine and secant have to be positive, which they are. And the tangent and cotangent must be negative, so I know the signs are correct. Okay. Example number 2. Now we're going to be simplifying a trigonometric expression. It says simplify the expression sine x cosine squared x minus sine x. Okay, let's do that. So solution, here's what we have to do, guys. This is kind of factoring the greatest common factor, but we're using trigonometry. So if you have sine x and cosine squared x minus sine x, don't they have the sine x in common? So my first step, guys, that's what I'm going to do. I'm going to factor out sine of x. So if I do that, we're left with cosine squared x minus 1. And you can always check your work. Sine of x times cosine squared x will give us sine x cosine squared x. And sine of x times negative 1 will give us negative sine. So I know this is correct. Okay, now we know that, or you guys should be accustomed that every time that you see something squared, right? And any trig expression that's squared, you're going to use the Pythagorean identities. Okay, so that's like a heads up there. You see, we're going to use sine square u plus cosine square u equals to 1. Let's see if we can get right. We know that if we subtract cosine from both sides, it's going to give us 1 minus cosine, right? But if you notice, are these the same? No, not quite. So I can do that, guys. You can do it 2 ways, by multiplying everything by negative 1, right? That's what I did. Multiply everything. If you multiply both sides by negative 1, that's the equal in mathematics, as long as you do it to both sides. So negative 1 times sine squared u will give us negative square u. Negative 1 times 1 will give us negative 1. And negative 1 times negative cosine square u will give us positive square u. If you notice, now the right side, I can rearrange it. And now it matches what we have over here on this side. Okay, if you notice. So we know that cosine squared x minus 1 is equal to negative sine squared x. Now, if we multiply these, right, we can. Here we're using like the same base, right? Like the powers, when you have a power to a power, right? I mean, when you have a base to a power times a base to a power, you add the exponents. So it'll be negative sine cube x. That's your result, guys. Okay, now let's continue with one from the 20 from the homework. This is very similar to the one that we just did. Okay, so again, what do both sides have in common? If we notice, they have in common sine squared x. So I'm going to factor that out. So if I do that, I'll be left with secant squared x minus 1. And again, this is like a hint that we have to go again to the Pythagorean identities. Okay, we have to go somewhere where you have secant squared, so it's going to be this one here, that tangent square u plus 1 equals to secant square u. Now here, guys, I can rearrange this, right? I can match this, what's here, I can subtract 1 from both sides, and it's going to give us secant square u minus 1, right, which matches what we're looking for. So, I mean, I'm going to plug in, right, tangent square u, or tangent squared x, where the secant squared x minus 1 is. Right, and that's my result. Right, because this is equal to the tangent squared x. Okay, now factoring, guys, okay? Factoring trigonometric expressions. So example 3, they want us to factor a and b. A is the secant squared theta minus 1, and b is 4 tangent squared theta plus tangent theta minus 3. Okay, I always tell my students to convert it to something quadratic, something that we should know how to do, right? From previous courses, from pre-cal 1. Okay, this, I'm going to let x be secant x. Then I'm going to let x, also for b, let x be tangent x. Okay, so if x is equal to secant x, so for a part, it's going to give us x squared minus 1. And this is something very, very common, guys. This is a difference of 2 squares. This will give us x minus 1 and x plus 1. If you guys struggle with factoring, okay, say you struggle with factoring, there's a PowerPoint that we did, but it's in the 1324, week 3, that I went over a PowerPoint on factoring. If you guys don't know how to factor, guys, well, then it's a little bit, you're going to be like in trouble, really, because this class, this section, this course requires factoring only for this section here. But when you get to Cal 1, Cal 2, and upper level courses, differential equations, you have to know how to factor. And if not, you're going to have a hard time because you have to know those are basic, the basic foundation for upper level courses. So if you don't know how to do something like this, guys, well then I recommend for you guys to actually go back to the PowerPoint. It's from week 3 for 1324, or just go to YouTube or watch some videos. And if you're in Trans Mountain, just hit me up for something numbers and I can help you. Anyway, x squared minus 1 is equal to x minus 1, x plus 1. Now let's go back and substitute the secant x for the x's. So this is my result. Secant theta minus 1, secant theta plus 1. Okay, now, B part is a little bit more challenging. Why? Because we have a 4 in front of the tangent square. So again, let's replace x with every tangent of x. So it's going to give us 4x squared plus x minus 3. Okay. Now, I like this one here. There's 2 ways to do these type of problems here. We have ax squared plus bx plus c. If a is a number besides 1, I like to do it by grouping because there's 2 ways to do it, that I know of. One is by trial and error, and one is by grouping. I believe grouping will be much simpler to do. Okay, here's how you group them. By grouping, guys, we're going to multiply the first term, the a term, times the c term. So 4 times 3 will give us 12. Don't worry about the sign, guys, okay? Just follow this method, and if you follow my method, you cannot go wrong. Okay, don't worry about the sign for now. Right? Then we have to get the factors of 12. How can we get 12? 1 times 12, 2 times 6, and 3 times 4. Also, guys, this sign tells us that we're going to be subtracting the factors to give me the bx term. So 12 minus 1 is 11. 6 minus 2 is 4. And 4 minus 3 is 1. And the match, guys, is going to be 1, right? So it's going to be 3 and 4. So before I do that, I'm going to make sure that 3 and the 4 is used to give me a positive x. So then it'll be 4x minus 3x will give me the x. Okay, now, guys, I'm going to go from 3 terms to 4 terms and do it by grouping. You see, guys, my 4x minus 3x replaces my x. Now, I'm going to do it by grouping. Okay, this I do by grouping. Hey, guys, first of all, let me go back in one. You guys just, what do the first 2 terms have in common? They have in common a 4 and also an x. right? If you take it out, what's left? X plus 1. Because 4x times x will give you 4x squared, and 4x times 1 will give us positive 4x. So I know this is correct. And again, if you go back to the week 3 video from 1324, I go more in detail here because, I mean, you should know this by now, because if not, guys, I mean, I'll take longer to finish all to finish this, and I only have like 50 minutes to complete this workshop. Okay, so now, guys, what you have here, guys, for what's left, the x plus 1, just put it on the right side. It's going to work all the time. So we're going to put over here x plus 1. The next step, the sign in the middle comes down. Then there has to go a number here. Something's got to go here. Okay, and here's how you tell what goes here in this slot. You can ask yourself, what number times x will give me 3x? So it's going to be 3. And again, you can check your work. 3 times x, negative 3x times x will give us negative 3x. And negative 3 times positive 1 will give us negative 3. So I know I'm in the right track. Now, we went from 3 terms to 4 terms to 2 terms. Now comes my answer. So you can ask yourself, what do these 2 terms have in common? The x plus 1. If you factor it out, what's left? 4x minus 3. This is my result, guys, of factoring. Now I'm going to go back and substitute tangent of x for every x. Or tangent of theta, right? Because here they're using theta. So this is my result. Tangent theta plus 1 and 4 tangent theta minus 3. Hey guys, this is crucial, guys, because I believe in section 5.3 or 5.4, I don't remember which one, you're going to be solving trig functions by factoring. So that's why you have to know how to factor, because you're going to be solving these. Okay? For example, if we were solving these, right, we would let it equal to 0, and then we will let tangent theta plus 1 equals 0, and 4 tangent theta minus 3 equals 0, right? And then you solve for x or for theta. That's what's coming up in I believe in 5.3. Anyway, this is my result, guys, for answer for B. Now, let's do 21. It's also, we have to factor to actually do this one here. Okay, now, again, factor the numerator and denominator if possible. So I know that the denominator cannot be factored, but the numerator can. Okay? Right, from before, right, secant squared x minus 1 is the same thing as secant x minus 1, secant x plus 1. That's for the numerator. For the denominator, it cannot be factored, so it stays at secant x minus 1. If you notice, you see we have secant x minus 1 on top as a binomial, and also on the bottom, so they cancel. And guys, they don't cancel because secant over secant and 1 over 1. No, they cancel because the secant x minus 1 is together. You cannot separate it. So we have the same thing on top and the bottom, so they cancel as a binomial. Okay, they cancel together like that. So my result will be secant x plus 1. That's your answer. Now let's factor this one here, number 25. Because when you have 4 terms, we're going to do it by grouping. Okay. Okay. Now we're gonna group the first 2 terms. Okay, the cotangent cube x plus cotangent squared x. What do they have in common? It's going to be they have in common cotangent squared x. So you factor out what's left, cotangent x plus 1, right? Because cotangent squared x times cotangent x will give us cotangent cube x. And cotangent squared x times 1 will give us positive cotangent squared x. Now, when you do it by grouping, guys, what you have here, guys, for what's left, you can also put it on the right side. The sign comes down. Now you can ask yourself, what number times cotangent of x give me cotangent of x? The answer is going to be 1. Because 1 times cotangent x plus 1 will give you cotangent x plus 1. Now, what do they have in common, these 2 terms? They have in common the cotangent x plus 1. What's left? Cotangent squared x plus 1. That's the result. It cannot be simplified any further. So that's your answer right there. Okay. Okay, now, because this is my answer, but it cannot be simplified, but according to the rules for the Pythagorean theorem, right, we go to these rules here because we have something squared, either cotangent, tangent, secant, cosecant, or sine or cosine. We go to the Pythagorean theorem, see if we can be simplified. Okay, now, we notice cotangent square u plus 1 equals cosecant square u. So I'm going to replace cosecant square u for the cotangent squared x plus 1. Now this is my result. Okay, cosecant squared x times cotangent squared x plus 1. Okay, and again, I forgot to go all the way through, guys, but you always go all the way through. Okay, like I did here. Now we're factoring a trigonometric expression. We're keeping factoring, but now you notice these are not the same. So what can we do? We're going to go back and use up our diagram identities. Okay. So since we have cotangent, I have to convert the cosecant square u into something with cotangent. Okay, so I'm going to plug cotangent square u plus 1 for the cosecant squared x's. You see, this is a cotangent squared x plus 1 is the same thing as a cosecant squared x. Now everything is in terms of cotangent. So we can add the 1 and the negative 3, so it's going to give us negative 2. So it gives us cotangent squared x minus cotangent x minus 2. Again, we're going to let x equals cotangent of x. So now to factor this one, guys, it's going to be it's going to be a binomial. And again, I just give you the answer, guys. But if you got this one, guys, this sign tells me the sign where the 2 is. It tells me the signs are going to be different. And this first sign, you always bring it down. Okay. Then you get the factors of 2. How can I get 2? It's just 1 times 2. And the sign here, guys, tells us that we subtract them because the constant term, right, which is the 2, that sign determines if we have to subtract. Since it's minus, we subtract them. Right? 2 minus 1 will give me my 1. Anyway, guys, this is my answer, guys. And again, if you need help, refer to the factoring PowerPoint or workshop that we did for the 1324. Now we go back and plug in cotangent of x for every x. And this is my final result. Cotangent x minus 2 times cotangent x plus 1. Okay, now we're doing number 30 from the homework. Okay, see, it kind of matches. So again, we're going to convert the sine squared x and something with cosine. So if we subtract sine squared u to both sides, it's going to give us 1 minus cosine squared u. So I'm going to replace 1 minus cosine squared u for the sine squared x. See, I replace 1 minus cosine squared x for the sine squared x. Now, right, I can combine the 1 and the 3. Now here, guys, I'm going to factor out a negative because I like to factor where the x squared is always positive. Okay. Now here, guys, I'm going to let x equals to cosine of x. And again, guys, when I factor out the negative, right, all the signs in the trinomial, they switch. You see, negative becomes positive, positive becomes negative, and positive becomes negative. Now we're going to let x equal to cosine 2x. So that'll be x squared minus 3x minus 4. Now this, I consider this the factoring with a x squared plus bx plus c form. So here, guys, right, this tells me the signs are going to be different. This is going to be negative and a positive, right? Then you ask yourself, how can I get 4? 1 times 4 and 2 times 2. And then we subtract the factors. That's why it's going to be 4 and 1. So this is my solution, guys, for this problem here. But now we have to go back and plug in cosine of x for every x. And here's my result. Negative, parentheses, cosine of x minus 4, close parentheses, open parentheses, cosine of x plus 1. Example 5, simplifying a trigonometric expression. Here, guys, they give us sine t plus cotangent t times cosine t. So convert every trigonometric expression to sine and cosine. Okay, we know that the sine's okay, but the cotangent is not okay, right? So we have to convert it to sine and cosine. Hey, guys, when you try to simplify some of the expressions, if you don't see the rule or the identity, a wise step is to convert everything to sine and cosine. Okay, and then from there you'll be able to see if you see something that can cancel or something that can be simplified more. So in this case, right, the cosine of t is equal to cosine t sine t. If you notice, here, guys, it's going to give us sine t plus cosine squared t over sine. Now, how can we add these? Right? I'm going to multiply. My LCD, right? The least common denominator is going to be sine of t. Right? That's my least common denominator. So the sine of t, I need to multiply it by sine t over sine t. Right? This is going to give us sine squared t plus over sine t plus cosine squared t over t. Now, cosine squared t plus cosine squared t is equal to 1, right, by the identity. So it's going to give us 1 over sine t. And sine t is equal to cosecant t. I should have put more here on the right, guys. I should have put the rules here. Maybe I can fix the PowerPoint for next time that I do these workshops. Because I believe for every slide I did that. I don't know why I didn't do it for this one here. Okay. This is number 37 from your homework. Again, use the Pythagorean identities to simplify. So 1, right? And here they are. So we're going to use for 1 minus sine squared for square x, right? We can use the first one. Sine squared u plus cosine squared u equals to 1. Okay. So cosine squared u is equal to 1 minus sine squared u. So I'm going to plug in cosine squared u or cosine squared x for 1 minus sine squared x. And also, guys, for the cosecant, right, we can use this one over here because it has cosecant squared. Because if you notice, if I subtract 1 from both sides, it's going to give us cotangent squared u equals to cosecant squared u minus 1. Therefore, guys, right, I'm going to plug in cosine square x for 1 minus sine square x. Then I'm going to plug in cotangent square x for cosecant squared x minus 1. Now, let's convert everything to sine and cosine. Okay, and see what happens from there. So we keep the numerator, which is already in cosine and sine form. The cotangent, right? Oh, here we go. You see, I wasted the last slide. I would have done it like this. So cotangent of x is equal to cosine over sine. So I'm going to replace cotangent with cosine over cosine x over sine x. Now here, guys, this is the same thing as cosine square x times, and then the second fraction on the bottom, you flip it. So it'll be cosine squared x times sine squared x over cosine squared x. If you notice, the cosine squared x cancel, right, is equal to 1. So the answer is sine squared, I should have put here x, guys, instead of u. It should be sine squared, squared x. That's my answer here. Okay. Now, guys, we're going to be adding trigonometric expressions. Okay, how do we add them? You know, guys, I left, this is the answer here, guys, but I should have put animation on this one. Okay, I got to go back and fix it. But for now, we'll just go like that. Let's see, guys. So to add them, guys, you have to find the LCD. The LCD between 1 plus cosine theta and sine theta is going to be sine theta 1 plus cosine theta. That's my LCD. So, right, so the first term, the sine theta over 1 plus cosine theta, right, is missing the sine theta. So I'm going to multiply both numerator and denominator by sine theta. And this is legal in math because you're multiplying by 1, which is legal. Now, for the second term, the cosine theta over sine theta, okay, what's missing is the 1 plus cosine theta. So I'm going to multiply top and bottom by 1 plus cosine theta. By 1, oh, this will be a plus because I did a mistake here. That's supposed to be a plus. Okay, but let's see what happens here. Right, this gives us, yeah, because that would have been a plus. It's going to give us sine squared theta, right? This will give us cosine times 1 will give us cosine theta, and cosine times positive cosine theta will give us cosine squared theta. Again, this is a mistake. It should have been a positive there. Okay. If you want, let's see if I can. You know, guys, I'll just fix it right now. Okay. Just wait. I'll just fix it. I know that, let me fix it real quick. No, you know that the answer is correct. Let me see here. Yeah, let me change this to positive. I apologize for that mistake. Positive. And this one has to have also animation. So let me put animation. Again, sorry about that. Let's put that. Okay, now guys, let's start here from scratch again, from the beginning. Let's go here, start from current slide. Here we go. Okay, let's try it again. You have to find the LCD. Right, so the LCD is 1 plus cosine theta times sine theta. So the first term, right, what's missing on the denominator is sine theta. So I'm going to multiply top and bottom by sine theta. And the cosine theta over sine theta, right, for the second denominator, what's missing is a 1 plus cosine theta. So I'm going to multiply top and bottom by 1 plus cosine theta. Okay, now, if we multiply sine times sine, will give us sine squared theta. If I multiply cosine theta times 1, will give us cosine theta. Cosine theta times cosine theta will give us cosine squared theta. On the bottom, guys, it's just going to give us sine times 1 plus cosine theta. Or reverse, right? It doesn't matter if what goes first. Now here, guys, notice here, right? Sine squared u plus is equal to 1. So I know that sine squared theta plus cosine squared theta is equal to 1. So I'm going to have 1 plus cosine theta on top. Because again, cosine squared theta plus sine squared theta equals to 1. That's where the 1 comes from. On the bottom right, we have the same thing. 1 plus cosine theta times sine theta. So now, right, these are the same. So those will cancel, or they can simplify to 1. So it's going to give us 1 over sine theta. And 1 over sine theta is equal to cosecant theta. So that's my result right there. Okay. Let's do number 7. It says rewrite a trigonometric expression. So we have to rewrite it that it doesn't have a fraction. Okay. I mean, here, guys, when you have something like this, guys, you multiply by the conjugate. Okay, now, what are conjugates? For example, if you have x plus 1, the conjugate will be x minus 1. If you have 1 plus sine x, the conjugate will be 1 minus sine x. So I'm going to multiply top and bottom by 1 minus sine x. Okay, now, on top, right, it's going to stay the same. It will just be 1 minus sine x. On the bottom, 1 sine x times 1 minus sine x will give us 1 minus sine squared x. Again, if you do the FOIL, the two terms in the middle will cancel, so I'm there with 1 minus sine squared x. Okay, now, what's 1 minus sine squared x? Right? Right, cosine square u equals to 1 minus sine square u. So we know that I can replace 1 minus sine squared x for cosine squared x. Now here, guys, I can separate these. Okay, this is legal to separate them. It's going to be 1 over cosine squared x minus 1 over sine x. Okay. Yeah. So now here, guys, there is right. We're going to be using that's going to equal to secant. But let me continue, guys. So here, guys, I'm going to separate this here. I'm going to put sine x over cosine x times cosine x. Okay. Now, I know that sine x over cosine x is equal to tangent. And again, guys, when you begin to practice and use the identity formulas, you always should have those at your disposal. This way, you can know what you can use. I know at first, guys, it's like a dead end at first, guys, because when I started, I mean, when I took this class in the year 2000, like 2007, something like that, 2006, I was having a hard time with these. But I just practice, guys, and then I began to get the concept. And I believe every student struggle with these right here. There's a lot of thinking, and you have to use those formulas. Okay, so my advice to you guys is just try it. Don't just ask for help. I mean, right away. Try it on your own. See if you can figure it out. And then if you can, then you can ask for help from the tutors or from your instructor. Okay, now, so this becomes sine x times 1 over cosine x. Okay, now here, guys, we know that that secant is equal to 1 over cosine. Well, I forgot to put the theta there. So then, this is going to give us secant squared x on the bottom here, guys. Minus, we know that sine over cosine is going to be tangent. So I'm going to replace sine x over cosine x with tangent. And 1 over cosine is equal to secant, right, again. So it's going to be, so I'm going to replace 1 over cosine with secant of x. And this is my result. You see, guys, I took out the fraction. It's only, there's no more fractions. And that's what they wanted you to do here. Okay, now guys, we're going to start 5.2. And again, guys, there's a lot of examples. They're in 5.1. And I believe this section is a little bit challenging, guys. I mean, 5.1 and 5.2 is a little bit challenging because you have to be thinking. When you get to calculus 2, it's where you're going to be using these. For Cal 1, you didn't use them as much, but Cal 2 is a must. So you have to know this for Cal 2. Okay, now, guys, for 5.2, we're going to be verifying trig identities. The first step that you do, guys, is work with one side of the equation at a time. It is often better to work with more complicated side first. Number 2, look for opportunities to factor out expressions, add fractions, or create a denominator with a single term. Number 3, look for opportunities to use the fundamental identities. Note which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents and cosecants and cotangents. I mean, there, guys, they're talking about the Pythagorean identities. When the preceding guidelines do not help, try converting all terms to sine and cosine. You see, that's the last resort. Convert everything to sine and cosine, and then you can see, try to see something that you can see to simplify. Always try something, guys. Even making an attempt that leads to a dead end can provide insights. Okay, so let's see here. Okay, and it's also, guys, there's different ways to get the answer. There's not only one way. There's different ways. It depends how students think. For example, right, we have to work on the left to make it look like the right. So what I'm going to do here, guys, I'm going to separate them. Okay, I'm going to make it secant squared x over secant squared x minus 1 over secant squared x. Okay, we know that secant squared x over secant squared x is equal to 1, right? And we know that cosine of theta is equal to 1 over secant theta. So I'm going to replace 1 over secant squared x with cosine squared x. Okay, you see it's color-coded here. Now I'm going to use the Pythagorean identities. 1 minus cosine squared x, you're going to go to the one that has sine and cosine, right? So here, guys, if we solve for sine, right, it's going to give us 1 minus cosine squared x, which matches what we're looking for. So my answer will be sine squared x. Because isn't it amazing, guys, that you have something that looks complicated and then you get a very simple answer? Yeah. Okay, now example number 2. Verifying a trig identity. So we have 2 secant squared x, I think that's alpha, is equal to 1 minus 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha. Okay, now, here, guys, I'm going to work on the right side to match my left side. Because it's really real hard or really like very challenging to go from the left to the right. So I'm going to work on the easier side. So we're going to go from the right side to the left. Okay, now I need to find my LCD. The LCD will be 1 minus sine x and 1 plus sine x. That's going to be my LCD. Okay. So the first term, the 1 minus sine x, right? The LCD is, we get the 1 minus sine x, but we're missing the 1 plus sine x. So I'm going to multiply by 1 plus sine x or 1 plus sine x. And the second term, right, what's missing on the bottom, right, is going to be 1 minus sine x. So I'm going to multiply top and bottom by 1 minus sine x. Now, right, what's 1 times 1 plus sine x? It's just going to give us 1 plus sine x on top. And 1 times 1 minus sine x will just give us 1 minus sine x. On the bottom, guys, it's going to give us, if you multiply these, it's going to give us 1 plus sine squared x. Okay. Now you notice sine x and negative sine x, right? That's equal to 0. So we're left with 2 over 1 minus sine squared x. Now let's see if we can simplify the denominator to make it look like secant. Okay. We know that to solve for to match this from the Pythagorean identity, we can subtract sine squared x to both sides. So secant squared u is equal to 1 minus sine squared u. So I'm going to replace cosine squared x for 1 minus sine squared x. Okay. Now this is the same thing as 2 times 1 over cosine squared x. And 1 over cosine squared x is equal to secant, right? Because since it's squared, we have to square also the secant here. So it'll be 2 times secant squared x. You see that it matches the left side. Now let's do example 3. Okay, we're going to work on the left side to match the right side. So here, guys, right? I'm going to do let's see here, guys. I'm going to use the Pythagorean identities. Because if you follow this, guys, if you multiply tangent squared x and cosine squared x and all that stuff, guys, it's going to give you like something real, like something real hard to simplify. So again, every time that you see something with squared, either a trig function or trig expression, go to your Pythagorean identities. So 1 plus tangent square u is equal to secant square u. So I'm going to replace tangent squared x plus 1 with secant squared x. Now sine square u plus cosine square u equals to 1, right? You guys here, guys, what I did here, this is what I did. Because I want the cosine to be positive, right? So what I did, guys, I left the cosine as positive. What I did, I subtracted the sine from both sides. From here, guys, right? So it's going to give us, let me see here. It's going to give us, no, we don't look at if you want, just switch all those signs. I think that'll be easier. That'll be negative, right? And that'll be negative, and that'll be negative. Now, you send the sign, you send the cosine to the right side, right? And it's going to become positive. So we have negative sine square u equals to cosine square u minus 1. So this replaces the cosine squared x minus 1 will be replaced by negative sine squared x. Now secant squared x, right, is going to give us 1 over cosine. It's going to give us 1 over cosine squared x times negative sine squared x. If we multiply these, it's going to give us negative cosine squared x or cosine squared x, which is equal to tangent. So it's going to give us negative tangent squared x is my result. Okay, that's my answer. Okay, now let's see here. I think this is the last one. Verify each identity. Yeah, because it's almost time here. And I was even thinking about putting more, guys, but I'm good that I did it because I would have passed the time because they only want us to do like no less than an hour because everything is time with these with these programs. Okay, A part. We have tangent of x, cosecant of x equals to secant of x. Okay. Again, we're going to work on the left side to match the right side. So again, let's convert everything to sine and cosine. The tangent sine and cosine, right, is going to give us sine x over cosine x. And the cosecant as sine and cosine is going to give us 1 over sine x. So I'm going to replace 1 over sine x for the cosecant. If you notice, right, the sine x and sine x, right, they is equal to 1 or they cancel. So we're left with 1 over cosine x, which is equal to, right? Then we use to the reciprocal identities. So it's going to give us, I believe, secant of x, and that's my answer. Okay. Now let's do B part. We have tangent x plus cotangent x equals to secant x cosecant x. So again, guys, right, we're going to convert tangent x and cotangent x to sine and cosine. So I'm going to replace tangent x with secant x cosine x. And the cotangent is going to be cosine over sine. Right, so I'm going to replace cosine x over sine x for cotangent x. Now, guys, I need to find the LCD. Okay. The LCD of sine x over cosine x and cosine x over sine x will be cosine x sine x. That's my LCD. Okay, so the one on the left, right, what's missing on the bottom is going to be the sine x. So I'm going to multiply by sine x over sine x. And the second term here, guys, cosine x over sine x, what's missing on the bottom is going to be the cosine x. So I'm going to multiply top and bottom by cosine x. So it's going to give us sine squared x plus cosine squared x, right, over sine x, cosine x. Now, we should become accustomed that knowing that this is one of the most famous ones, guys, this Pythagorean identity. By now, guys, we should know that this is equal to 1, right? So I'm using this one here because this one is the one that's mostly used. So we're going to have 1 over sine x cosine x. Now here, guys, I can separate them. This is going to give us 1 over sine x will be cosecant x. And 1 over cosine x will give us secant x. So my answer will be cosecant x and secant x. You see, guys, it matches the right side, even though it's not the terms are not in order, but that's okay because if you multiply it, it doesn't matter. And that's my result, guys. Okay. A question, guys. So I believe, guys, that's it for this PowerPoint. Let me take you back to the host so they can tell you more about what's coming up in future. What's coming up next today. Let me go back here.
Thank you, Mr. Istasi, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on our YouTube playlist. Today's session will also be available on that playlist later on today. Also linked is a short survey to help us improve our TV sessions. Please take time to fill out that survey. Before you leave, I want to share the TV sessions that we will have next. We will be back with Happy Math Hour next week, which Math 1332 will be covering Exam 2 review. And Math 2412 will be covering the laws of sines and cosines. Today at 1 p.m., we will have the student success topic. Today's topic will be the degree works, and this will be presented by Sonia Santana and Astrid Arciniega. Thank you all for coming in today. We hope that you all have a lovely weekend. If you have any questions, feel free to use your chat box or mic. Once again, have a great weekend. Thank you.